In this video, we're going to be talking about Aldol reactions. So, if we were to have an aldehyde, such as this, and reacting with a strong base as a catalyst, what would happen is that this base is going to come in and deprotonate the alpha hydrogen in blue there. It's going to take that alpha hydrogen, and this is going to generate an inolate ion, like so. And then what is going to happen next is that this inolate ion is going to come in and react with another aldehyde at the carbonyl-carbon, breaking the double bond. And this is going to give us our aldol addition product. And it is going to look like this. This is going to actually create a alkoxide ion, but then it's going to react with water, and this is going to give us back our base. It's going to regenerate the base, and it's going to give us our final product, which will look like this. So this is called a self-Aldol reaction because it is reacting with itself. This is the starting material that we formed the enolate from. So after we formed our aldol addition product, what will happen is that if we were to slightly heat this under basic or acidic conditions, I should also mention that Aldol reactions can happen under either basic or acidic conditions. We're not going to go over the mechanism for acidics because it's a bit more involved, but the condensation reaction, which is going to be heating the aldol addition product under either basic or acidic conditions, generally will always happen in a laboratory setting because this is you're going to be creating the aldol reaction in a basic or acidic condition anyways. So in a laboratory setting, generally you're going to get the aldol condensation product instead of the actual aldol addition product. So that is something to keep in mind. So the aldol condensation is going to happen like so. This OH hydroxide ion is going to come in and deprotonate at the alpha hydrogen, deprotonate the alpha carbon and take the alpha hydrogen, and this alpha hydrogen is going to do that, and this is going to kick off the OH group and form a double bond. So first it's going to form an ion, and then this ion is going to kick off the OH group and form a double bond. Like so. And this is a alpha beta unsaturated aldehyde. You can see it is between the alpha and beta position of from the carbonyl. So this is mostly what you would see as the major product of a Aldol reaction. Next, we're going to go over intramolecular Aldol reactions. So particularly between, say, diketones, if we were to have a 1, 2, 3, 4, 5, 6, 7, let's say we have a 2, 6 diketone. And if we were to react this under basic conditions, this is going to undergo a self-Aldol reaction intramolecularly, and it's going to cause a ring formation. So we can either deprotonate at the alpha carbon at carbon 5, or we can deprotonate at the alpha carbon at carbon 7. However, if we were to deprotonate at carbon 5, this is going to form a 1, 2, 3, 4 membered ring, and that is a 4-membered ring is quite unstable. And if we were to deprotonate at carbon 7, it is going to form a 1, 2, 3, 4, 5, 6 membered ring, which is going to be much more stable. So this is going to, the major product for this reaction will mainly be a 6-membered ring. So let's do that now. 6, 7. Deprotonate there. And this is going to attack there. Let's draw it a bit differently. So, and this is going to form a 6-membered ring. Like so. So let's call this carbon 1, 2, 3, 4, 5, 6, 7. So let's say this is 2. 1, 2, 3, 4, 5. Sorry. 1, 2, 3, 4, 5, 6. So at 2, there's going to be a oxygen double bonded, and at 6, there is going to be a methyl group from here, from carbon 7. So this is carbon 7, and a alkoxide, and this alkoxide is going to react with water to give us our final Aldol addition product. And this product can also undergo Aldol condensation. So water is going to be removed. This OH is going to be removed, and this alpha hydrogen here is going to be removed and form a double bond. And this is going to give us our condensation, our alpha beta unsaturated ketone, like so. And notice how the in these alpha beta unsaturated ketones, the double bonds are conjugated, so, for stabilized by conjugation. So next, let's go over cross Aldol reactions. So if we were to have the aldehyde that we've been working with, and were to have another aldehyde, these two can react and form an Aldol addition product. And also, just another thing I want to mention why it's called an Aldol addition product is because it has a aldehyde functional group and a alcohol functional group. Therefore, an Aldol addition, Aldol reaction. And just to note that this can also happen with 2 ketones, or it doesn't have to be aldehydes. In a cross Aldol reaction, under basic conditions, let's call this reactant 1, and let's call this reactant 2. Reactant 1 can react with itself, undergoing a self-auto reaction. We've seen that earlier. And reactant 2 can also react with itself, undergoing a self-auto reaction. So, and then reactant 1 and reactant 2 can undergo auto reactions, and reactant 2 and reactant 1 can undergo cross-auto reactions. Sorry. So there's going to be 4 different products that you can get from this cross-auto reaction, not including isomers. If you include isomers, then it's 8 because you can get cis or trans isomers from Aldol reactions. So let's do this. It depends on which alpha carbon that you depronate. So if we were to depronate the alpha carbon of reactant 1, it is going to give us a different product than if we were to depronate the alpha carbon reactant 2. So reactant 1 is going to attack the carbonyl carbon. The enolate ion is going to attack the carbonyl carbon and break the double bond and create a alkoxide ion. So that will look like this. That will create a product that will look like so. And this reacts with water to give us our Aldol addition product. This will then undergo condensation, where it will be heated and under basic or acidic conditions. And this is going to give us a alpha beta unsaturated aldehyde. If we were to depronate the alpha carbon of reactant 2, this is going to attack the carbonyl carbon the same way. And this is going to give us a alkoxide. Sorry. Single bond OH. Alkoxide, so. And this is going to react with water to form our Aldol addition product. So notice the difference between these two products depends on which reactant's alpha carbon that you depronate. So this can also undergo Aldol condensation, where it will remove a water molecule and form an alpha beta unsaturated aldehyde, because the double bond is formed between the alpha and beta positions from the carbonyl carbon. Lastly, I want to go over how we can get back to the starting materials from the Aldol condensation product. So if we were to have this Aldol condensation product, let me just redraw here. And we want to get back to the starting materials from this product. There's actually a very simple way to do this. All you gotta do is just to split at the double bond, and it is going to give us back our starting materials, which will be our reactant 2 And our reactant 1, we're going to keep the double bond on the part with the aldehyde carbonyl, the beta part, and we're just going to add oxygen to it, and this is going to give us back our 2 starting materials. So this is reactant 1, this is reactant 2, as you can see, reactant 2 and reactant 1. Sorry, 1 and 2 in this case. I numbered these wrong. But this is a very simple way to get back to the starting materials. It also works on this ring structures. So if we were to have something that looks like this, in order to get back to the starting materials, all we gotta do is to cut this at the double bond, the alpha beta double bond, and it's going to give us back our starting materials, which are going to look like this. And this is a 1, 2, 3, 4, 5, 6, 7, and this is the same as this. 2, 3, 4, 5, 6, 7. And this is a starting material for our Aldol reaction. Just one more thing I want to note before ending this video is that in cross Aldol reactions, we can use reactants such as formaldehyde, which do not have alpha hydrogens, and this cannot undergo self-Aldol reactions, and we can use these reactants to eliminate possible products that we might not want. So mainly things that do not have alpha hydrogens, things like, say, benzaldehyde, this alpha carbon there does not have any hydrogens on it, so these materials cannot actually undergo self-Aldol reactions.